Welcome to the BTEC Level 3 Engineering Diploma. My name is Mr. Richards and I am the head of the Design and Technology Department at St Margaret's Academy. Engineers are a group of people who have helped develop this modern world. They're the people who send rockets into space, the people who design bridges so you can travel vast distances, the people who produce engines so that we can move along in cars. Engineers are people who solve problems, and we need lots of them. Engineering is a wide discipline. There are lots and lots of different areas of engineering, and it is highly sought after. If you are trained as an engineer, your employment prospects are strong. In St Margaret's, our engineering course has 10 units. Some of those units are externally assessed with public examinations, but the vast majority are internally assessed by teachers who know you. The vast benefit of this is that you can be very much in control of your overall grade by the coursework that you produce. We can train you on industry standard CAD packages. We will train you to use machines and tools to be able to produce high quality products. We will train you how to use mathematical and scientific principles to be able to solve problems. We will train you how to use design skills to be able to design and produce high quality products. The engineering course at St Margaret's offers you a wide and broad knowledge base to be able to move on as an engineer. You'll be able to apply for university courses or apprenticeships, and you'll have a strong portfolio to be able to show to future employers. I believe that the engineering course at St Margaret's has been very successful. There have been a lot of students who've come from inside the school and from external applicants. All have been embraced and warmly welcomed, and they've been successful in their ambitions. In the rest of this presentation, I aim to explain more about the details of the course, and we would look forward to seeing you in our next cohort of students.
The entry criteria for the course are Grade 5 in GCSE Maths and either Grade 5 in GCSE Design and Technology or Grade 5 in GCSE Electronics or a merit in a relevant Level 2 qualification or a Grade 5 in GCSE Physics or a Grade 5/6 in GCSE Science. The teachers for this course are Mr Flannery, Mr Jones and Miss Lowe-Lieb. I may also join the course depending on the timetable. The exam board is Pearson's BTEC and the assessment is 33% examination, so 2 units equivalent to 120 guided learning hours of work, and 8 units which make up 67% coursework. There are 10 units in this course and they are spread out across the 2 years of study. Unit 1 is an examination and that is taken at the end of Year 12, and Unit 3 is an examination and that is taken in the January of Year 13. The benefits for this are, before you get to the very end of your 2 years of study, you will have completed the 2 external examinations, and you should also have had the results for those external examinations. So that helps you know what grade you are likely to get. The rest of the 8 units are spread across the 2 years of study. Each unit is worth around about 60 guided learning hours, and within the units you will complete practical hands-on work or written assignments or design-based assignments. The huge benefit to this is 67% of your overall qualification comes from coursework where you can sit down and think about your answers and you're not rushed and you have time to work on quality work that you can submit across the period of 2 years. Unit 1 is all about your mathematical and scientific ability to solve problems, and it is similar to A-level maths and A-level physics. You'll encounter a wide range of different topic areas which will help you understand the basics of how to solve problems using maths and science for engineering scenarios. The exam is a 2-hour external exam. It's a mixture of short and long answer questions. So it's the type of format that you'll be used to sitting for GCSE maths and GCSE physics. Unit 3 is quite different. Unit 3 is a timed exercise. You will get given a scenario which is to do with an engineering problem, and you'll have some time to investigate that scenario. It could be about a motor that's suspended on a bracket and the motor is failing somehow, and you then have some time to investigate what could be going wrong. You then have an 8-hour design challenge, which means you'll be sat in exam conditions spread out over a course of a number of days, 2 to 3 hours per day, and you will have to come up with design solutions to overcome the problem. This is a very real life examination. This is the kind of thing that a real engineer would have to do. They'd be given a problem, they'd be given a time in which they need to fix the problem, and they've got to come up with a design and a solution for that problem. The coursework units are all internally assessed. They can be practical assessments, written assessments, they can be individual or group assessments. The benefit of this is you get time to work on your assignments, you get time to practice your skills before you submit the final version of your assignment, and it'll help build up your skills to be able to cope with day in, day out work-based scenarios that you're likely to face if you do become an engineer. Engineers make lots of different types of products. In Unit 2, you'll learn how to manage that process. You'll learn how to be an effective team member and also how to be an effective team leader to get your team to be able to design and make a high quality product. Unit 4 is about the business aspects of engineering, about how to run a company to make good profit. It's about the quality that you need to put into place, it's about the business activities that you need to conduct, and the legislation that you need to adhere to. Unit 5 is an engineering project. This is bringing together a lot of your skills to be able to design and make a product that solves a specific given problem. You need to manage the project to complete it on time and make a high quality product. This is very similar to what an engineer would have to do in real life. In Unit 10, you'll be trained in a vital aspect of engineering, computer aided design. You'll be able to use 2-dimensional drawing packages and 3-dimensional drawing packages. So you'll use 2D design and SolidWorks. This is a really key component to being able to work out what a product would look like in 3 dimensions. You can export drawings from it, you can rotate it and see what the design looks like in 3D. This is a massive area of business for engineers, and it's the way that we would communicate our ideas to people all around the world. Unit 22 is about the production of electronic printed circuit boards, and we use those massively in engineering. So inside your phone there'll be PCBs, inside computers there are PCBs. It's a massive area of engineering business. In Unit 24 we explore how things that we've already made can then be maintained. So car engines need to be maintained, our buildings need to be maintained. So we look at the maintenance of mechanical systems. In Unit 41 we explore how we use machines to shape materials. So this is secondary machining processes. So traditionally we would use turning machines, so lathes and milling machines, to remove material to shape the product to the desired requirements. This involves a lot of accuracy and a lot of skill. In Unit 44 we will produce a fabricated design. That means taking raw materials, cutting them to the right sizes, marking them out accurately, and then joining them to assemble them into a complete product. Again, this is another large area of manufacturing and engineering. So these two units, 41 and 42, will give you a very good starting point to understand how engineers actually manufacture the parts that they can design. Here we can see a couple of current Year 12 students using a CAD package called SolidWorks to design an Art Deco mirror. We can see the CAD package, you're able to spin the items round and view them in an exploded view, or apply renders to them to make them look more realistic. This is an industry standard package. Just by learning this type of skill, you could equip yourself for jobs in the future. Electronics is a big part of our life, and it's a big part of engineering. You can see here a Year 13 student using a CAD package called Circuit Wizard to simulate the design of a circuit so that it can be then transferred into a printed circuit board. The Design and Technology department at St Margaret's Academy is very well equipped. It's probably one of the best equipped departments in the city. We have several rooms, including our own ICT suite and electronics room. We have a significant amount of machinery, several large CNC machines. We also have a breadth of knowledge as a staff. So we have engineers and professional designers who teach the courses. We also have additional STEM type projects. So STEM is science, technology, engineering and maths. One of those projects is our Green Power Cars project. So we purchased 2 electric powered cars, and the students are able to work on those cars as part of the projects if they identify a problem that they want to solve. You'll see a video explaining a bit more about this on the next slide.
The Goblin car will be used to demo STEM to children in primary schools, while our bigger Formula 24 car will actually be used in green power racing events. This chassis cost £1,800, but we've already noticed it does have some major drawbacks. First and foremost, it is incredibly heavy, and this will certainly slow down the car. Plus, the tyres suffer from rolling resistance and hysteresis, which is a bulging at the bottom that causes energy loss in the tyres. We're also looking at creating a very aerodynamic shell to counteract the issues, and it should, in theory at least, provide some extra performance on the Formula 24 car. Speaking of aerodynamics, we've already designed some bodies in our wind tunnel that we built in STEM Club, and we've already investigated laminar and turbulent flow on the bodies. Laminar flow is where the air sticks to the car as it flows past it, and turbulent flow, or eddies, are where the air is moved away from the car and causes drag, which will slow down the car and reduce performance.
Hi, my name's Janie. I am currently in Year 13 and studying engineering at St Margaret's. Engineering at St Margaret's is great because you're taught a wide range of topics. Some of these topics are based around design, where you are in the workshop manufacturing products. Other units where CAD software is used, which is really helpful if you want to pursue a career in engineering or design. The teaching in the department is great. All the teachers want to help and support students wherever they need it. The engineering teachers are always easy to find because they usually aren't far from the department, so you can go up and ask any questions that you need or ask for any help from them, and they will happily give you any help you need. I am currently taking product design alongside the engineering course. This combination is ideal for anyone who's looking into any engineering or product design career path because it gives you such a wide range of knowledge for both subjects. Some sections of the course intertwine, such as CAD software units or design units, which I've previously mentioned, so you'll get plenty of practice and time in the workshops for both subjects. I will be taking a product design course at university this September, and I am completely confident in my design abilities because of the courses and the teaching I've received at St Margaret's. St Margaret's is just a really nice environment. I found it easy to settle in, easy being in school, and enjoyed both my subjects, which I haven't really experienced previously, so I would really recommend studying engineering at St Margaret's if you're interested in engineering or design, because both subjects are really good in St Margaret's and they cover them really well, so you have a good basis of knowledge on both subjects.
Hi, I'm Emily. I'm a Year 13 student and I study BTEC engineering. I chose this course because I would like to be a mechanical engineer in the future, and this course could benefit me in many ways. The course has maths, physics and engineering as 2 subjects, not as 3. It also has a lot of coursework, which if you struggle with tests, it will help an awful lot, and it will even help boost your grades. I love that even though we are studying engineering, we also learn things like how to run a business, which could really come in handy in the future. The key things I learned are that you can always ask for help. Even if you are miles behind, the teachers will make sure they will get you the grade that you want. Every teacher has been lovely to me, and even if you don't understand something, they will go out of their way to help you. Coming from a different school, I can really see the difference in support and how good of a choice it was moving here. In engineering, we have many machines, and we get taught how to use all of them. It is very strict, so we're always safe. If I wanted to get teacher support, all I'd have to do is email them or walk to their classroom, as their door is always open. As I said, I want to be a mechanical engineer in the future, and to do that I did need maths and physics, but I didn't have the grade for this, so this course helped me be able to go to university. The reason why I'd recommend this course is because I know I enjoyed it and that others will too. I'm going to uni with manufacturing skills I never would have gotten if I'd taken maths and physics. Also, with being older, you are treated differently, as in more mature, and you are given more responsibilities. Also, the coursework here will be a huge help when you go to university, as there is a lot of coursework when you do go there. So overall, this was the best choice I could have made.
This course can lead you on to higher education, apprenticeships and employment. Engineering is a massive part of industry. People who take STEM qualifications, science, technology, engineering and maths, are in high demand. So if you take this route, you are likely to be very employable, and you are also likely to earn a lucrative salary. So the prospects are quite wide and varied. There's lots of different avenues that you could follow after this course. There's lots of university courses or apprenticeships that you could apply for. If you have any questions about the course, then you can contact me using the email address below.